All right, so good morning, students. What we will do is we will discuss today a topic of oblique collision. Okay, what is oblique collision? And so the context I will tell you is that you have a surface like this. So you have a surface. Okay, the surface is a smooth surface. Okay, so we will talk about a smooth surface and a smooth sphere that strikes the surface. So you have this surface. Okay, this is the smooth surface. Body comes and strikes it obliquely. Okay, so maybe it comes like this. Okay, and goes back like this. Okay, let this angle be alpha. Let this angle be beta. Okay, so I'll just repeat. See, this is a very important topic because it has multiple things inside it. Okay, it has the concept of momentum, impulse, and coefficient of restitution. Everything included. Okay, so this kind of question you can expect in NEET examination as well as in the JEE mains examination. So you can go to my playlist of mechanics and see a lot of mechanics numerical being solved in the playlist. It's a very important topic if you're studying for NEET and JEE mains. A lot of questions are asked on this topic of mechanics. Okay, so let's go back to this question. So this is the velocity with which you are coming and approaching the smooth surface. So what we are talking about, this is a smooth surface. Okay, so this is the smooth surface, and what you have is a spherical ball which comes and strikes it. So this is a spherical ball, very small, point, like a point mass, but this also is a smooth sphere. Okay, so you have a smooth surface, you have a spherical ball approaching the smooth surface and striking the surface and getting rebound. So this act of the body coming here and striking back is called as rebound. And the act of body coming here like this is called as approach. Right? So this is the approach part. This is the approach part. This is the rebound part, right? So it comes with u velocity at an angle alpha. It gets rebounded with a velocity v and angle beta. Okay. The question is, how do you analyze this situation? Okay, I'm not treating this as a numerical, but more of the concepts I just told you, which is coefficient of restitution, impulse, and change in momentum. Alright, so let's talk about it. So if you notice, the body has come here, struck. So I can do one thing. I can take a vertical axis here. This is my vertical axis. Okay, so this is my y-axis. And now the resolution of velocity can be done. So let me resolve this velocity into two parts. Okay, so this is the component which is u sine alpha. This will become u cos alpha. Okay, so this is u sine alpha, u cos alpha, and this is the resolution of velocity v. One is v cos beta, the other is v sine beta. So you have now a situation where we have resolved the velocities. Let us see what exactly is happening. Okay, so first thing, it's a case of collision, remember, right? But the collision is between a smooth surface which is of infinite mass, and then a small mass, a ball comes and strikes it and gets rebounded like this. Okay, I hope this is making sense. Let's talk about the momentum. Okay. Now the momentum, okay, the momentum in x-axis. The new x-axis is this, and then y-axis and y dash is this. Okay, so this is your x-axis, this is your y-axis that comes from resolution. Now, if you talk about the situation of momentum in x-axis, the momentum, initial momentum in the x-axis is m into u cos alpha, right? So this is the positive, and the momentum after the body has rebound in the x-axis will be m into this velocity. Okay, so this is mv cos beta. So this is gone, and u cos alpha comes out to be v cos beta, which means that what I've done is I have specifically conserved the momentum because I don't see any external force. The two surfaces, the surface of this particular surface and the sphere, both are smooth. So there is absolutely no any type of force which is involved that acts on either of bodies, right? So the momentum remains conserved. So I have applied law of conservation of momentum in x-axis. Okay, let's see what is happening in the y-axis. In the y-axis, if you notice, the momentum is in the downward direction like this, and the velocity is going in this direction. Okay, so if you notice, the real rebound is in vertical axis. You go like this, but when you go back, you actually are here, right? So these two are also analogous, right? So these are in y-axis. Now we know what is the concept of coefficient of restitution. The coefficient of restitution talks about what? It comes because of loss of energy, right? There is no E is a representation of the fact that how much energy has been lost. So when we talk about E is equal to how much, will be equal to the velocity of rebound divided by the velocity of approach. Okay, this is E, the velocity of rebound divided by. So if I